Welcome to Lesson 8 of Linux Hardening Mastery, where we stop talking about prevention and start building evidence. AppArmor prevents, audit.d records. That's the pairing we're locking in today. A kernel-level audit trail, stride-mapped rules dropped into audit.rules.d, and events shipped straight to your SIEM. By the end, every Syscall that touches sudoers, AppArmor profiles, or unauthorized binaries leaves a forensic-grade trace, the kind HIPAA, PCI DSS, and SOC2 auditors actually accept. So why audit.d and not just syslog? Because syslog tells stories, and stories can be edited. Apps log what they choose. Attackers rewrite the lines. Root can wipe the file. Audit writes from the kernel before user space ever sees the syscall. Fixed key-value records append only every syscall you mark. That's the gap between looks like X happened and X happened, here's the syscall. Don't replace syslog, stack them. Syslog for ops dashboards. Audit.d for compliance and forensics. So let's read one. -w names the watch, the file or directory, here, etc., sudoers. -p sets the permissions that trigger it. W for write, A for attribute change. You can also add R and X. And -k tags the event with a key, so ausearch, k sudoers pulls every hit back instantly. Watch, path, perms, key, 4 pieces, 1 rule, every touch recorded. One note, W is for files. For syscalls you'll use A with a filter, and we'll get to that on slide 5. Now rules without intent are just noise, so we map everyone to stride. Sudoers, pass.wd, shadow, AppArmor profiles, ss-dam config, all tampering because each one rewrites the trust boundary. Auth.log gets watched for repudiation, the classic attacker move of erasing their own footprints. Exec catches elevation, every binary run on the box. Socket catches information disclosure, every outbound connection. 8 rules, 6 categories, 1 defensible baseline, and notice the through line. Sudoers from lesson 2, AppArmor from 7, SSH from 1. Same threats, different layer, now with forensic evidence. Now where do those rules actually live? Same drop-in pattern as sudoers.d from lesson 2. Numbered files in, etc. audit.rules.d, each owning one concern, base config, tampering, execution, network, and a final 99 immutable to lock the rule set until reboot. Never edit audit.rules directly, organ rules assembles it. And after loading, you want to see loss 0, backlog 0. Anything else means events are being dropped. And dropped events are exactly the ones an attacker wants gone. So your rules are loaded, events are flowing. Now you need to read them. The log is binary, so grep is useless. Ausearch queries by key, time, user, or syscall. Aureport summarizes. Notice the OID field. That's the original login UID, surviving sudo and su, so privilege escalation can't hide the human behind it. 5 queries cover 90% of incident work. Who touched sudoers, top users, exec events per user, failures only, and JSON straight into your CM. But here's the uncomfortable truth. Querying local logs assumes the logs are still there. An attacker with root wipes audit.log in one command, and immutable rules don't protect the file itself. They only protect the rule set. The fix is audisp remote. Stream every event off the box the instant it's written. Use Kerberos for transport, set a deep queue for network blips, and choose your failure mode deliberately. Halt if you'd rather panic than lose evidence. Syslog if availability wins. PCI DSS 10.5.3 and HIPAA don't ask politely. Central log storage is required. Now, with logs streaming offsite, let's talk cost, because audit isn't free. Every syscall rule fires for every matching call by every process, and on a busy server, exec alone hits thousands per second. 2 patterns keep you sharp. Exclude the predictable noise first, cron, systemed kernel background work, because audit evaluates top-down, so a never rule at the top saves every downstream check. Then right-size the buffer, double the default to 16.384, and verify under load with audit.ctls. If loss is non-zero, you're dropping evidence. Measure before you tune, only act when loss exceeds 0 or CPU climbs past 5%. Performance tuned, let's turn audit back on the controls themselves. An attacker with root will try to disable what's stopping them. Comment out a sudo as line, drop an AppArmor profile, slip a key into sshg config. These 4 watch rules call back to every prior lesson. SSH from lesson 1, sudo from 2, the account database from 4, AppArmor from 7. Write and attribute changes, all keyed for ausearch. Then run one daily CM query across those 4 keys. Any new event today is by definition someone touching a control that shouldn't be moving. That's tamper detection. 5 gotchas that have burned real deployments. Naive exec rules without architecture and UID filters will eat 15% CPU and overflow the buffer. Events drop, evidence vanishes. Edit audit.rules directly and organ rules wipes it on reboot. Always use the rules. The drop-in pattern. Forget the immutable, E2 flag and root just runs audit.rules.d mid-attack. Watch a file but miss the temp file dance visudo does, and ausearch comes back empty. And the big one, local only audit.d means root deletes audit.log, and forensics gets nothing. Ship to a CM via audit remote, or you don't really have an audit trail. Step back and look at what you've built. 6 skills and your audit trail is live. Audit outranks syslog because it's kernel written, append only and accepted by PCI and Hyper. You know rule anatomy. You've mapped every rule to a stride category. You've laid them out in rules. D. You can query with ausearch and aureport. And most critically, you're shipping off-box via audit remote. AppArmor prevents. auditd records. Next, Lesson 9 closes. Stage 03 with systemd, where protect system, private temp, and no new privileges make much of that per-service hardening declarative, one line at a time. Lesson 8 is complete. Your audit trail is active, stride rules in place, rules.organized, ausearch at your fingertips, and events streaming to your SIEM. Lesson 9 closes. Stage 03 with systemd, where protect system, private temp, no new privileges, and capability bounding set give you AppArmor light hardening declaratively, one service block at a time. Load it up and let's finish what we started.